Electrostatics, chapter 1 of 12 science, electric charge and electric field. In standard 11, you must have gone through the chapters like thermodynamics, SHM, waves, mechanics, etc. Now, in this 12th standard, you will study mainly about electricity, magnetism, and then combination of electricity and magnetism. That is mainly part 1 of 12 science is composed of electric charge, electric current, electric field, magnetic field, electromagnetic waves. That is, it is combination. First 2-3 chapters will be of electricity, 2 chapters will be of magnetism, and the remaining 2 chapters will be the combination of electricity and magnetism, right? Now, we'll start with chapter number 1, right? Electric charge and electric field and electrostatics, right? Now, what is electrostatics? Right? Electrostatics is basically a branch of physics, just as you must have discussed about thermodynamics in your 11th standard. Thermodynamics is also a branch of physics which deals with conversion of heat energy into various other forms of energy, right? Similarly, electrostatics, it is a branch of physics where you will deal with study of charges which are at rest. You will deal with study of electric charges which are at rest. The name itself is made up from this. Electro means related to electricity. Electro means related to electricity. Statics means which are at rest. Which are at rest. So now in this particular chapter we will discuss about electric charge, Coulomb's law, what is electric field, then we will go for electric potential, capacitance, Gauss law, etc., etc., right? So the branch is very large and extended, but you will enjoy the concepts of electricity, electric charge, magnetism. Now, as I said that electrostatics means it is a branch of physics where you will deal with study of charges at rest. Charges at rest. Statics means which are at rest. Electro means related to electricity, right? Okay. Now, you must have definitely heard the name charge, right? And you must have heard about this also. If there are two positive charge, they will repel each other. Positive negative charge, they will attract each other. Negative negative charge, again they will repel each other, right? This is something you must be knowing about the charges. Now, first of all, what is charge? What is electric charge, right? Okay. So I can define charge as it is the property of a matter due to which repulsive, attractive, this all forces are produced. Once again, electric charge means it is the property of the matter. It is the property of matter due to which electrical or electric and magnetic effects are produced. Effects are produced. You said that two positive charges will repel each other, two negative charges will repel each other, positive negative will attract each other, right? So this is all because of charge. So charge is the property of a matter due to which electric and magnetic effects are produced. Now, how magnetic effects are produced, that we will discuss later on. This video is completely about the introduction of electrostatics. We'll go through the topics later on, right? Now, charge is the property of a matter. Matter means mass, right? It is a property of a matter. Matter means mass. So, first point will be charge will exist only if there is mass, right? Charge will exist, or you can say that if there is charge, there will be mass, right? Because it is a property of a matter, property of mass, right? So charge exists only in presence of mass, right? Converse might not be true. It's not compulsory that if a body is having some mass, will have some charge. That is not compulsory. वो compulsory चीज़ नहीं होती है. लेकिन कोई बॉडी के पास अगर चार्ज है तो उसके पास मास तो होना ही चाहिए. क्लियर? देयर कैन नॉट बी एनी चार्ज विदाउट मास. नाउ mainly there are different types of charges, but we will discuss only 3 charges: proton, neutron, electron. Proton, neutron and electron. What is the charge on proton? What is the charge of neutron? What is the charge of electron? What are their masses? How electrical forces are produced? How to calculate them? These are all the things which we will discuss in this particular chapter. Okay, fine. You must be knowing that mainly there are 2 types of charges: positive charge, negative charge. There are 2 types of charges: positive charge and negative charge. Make very sure that positive charge and negative charge are just the sign convention given. It does not mean that positive charge is more or the value of positive charge is more than negative charge. No, they are equal. Let me say you, like charge on proton is 1.6 into 10 raised to minus 19. So charge on electron is minus 1.6 into 10 raised to minus 19. Right? This doesn't mean that charge on proton is more than charge of electron. No, they are same. Just to distinguish, they are been given with sign. Right? Benjamin Franklin, I think, he was the scientist who has given the polarity on the charge, that proton will have positive charge, electron will have negative charge. If you are being asked this which charge is greater, charge on proton or charge on electron, then you will have to say that charge on proton is definitely equals to charge on electron. Right? Now we'll go through the units of charge. Right? In standard 10 you must be knowing that the SI unit of charge is coulomb. Right? So I will have to write it as charge on proton is 1.6 into 10 raised to minus 19 coulomb. Right? So coulomb will be the SI unit of charge. Okay, apart from coulomb there are some different unit of charges like CGS unit of charge. SI unit is coulomb. Similarly, CGS unit of charge is, you can say, state coulomb, ESU, Franklin. These are all the CGS unit of charge. State coulomb, ESU. ESU stands for electrostatic unit. Electrostatic unit. Right? So these are all CGS unit of charge, and 1 coulomb is equals to 3 into 10 raised to 9 state coulomb, or you can say ESU, you can also say Franklin. Right? Apart from this, there are some other unit of charges like EMU. 1 EMU equals to 10 coulomb. 1 absolute coulomb is also equals to 10 coulomb. These are some magnetic unit of charges. EMU stands for electromagnetic unit, which is equals to 10 coulomb. 1 absolute coulomb, this is also equals to 10 coulomb. And the largest unit of charge is Faraday. Largest unit of charge is Faraday, and 1 Faraday is nearly 96500 coulomb. Right? So these are some different unit of charges apart from coulomb. CGS unit of charges, state coulomb, or you can say ESU or Franklin. ESU stands for electrostatic unit, and the relation between coulomb and state coulomb is 1 coulomb is equals to 3 into 10 raised to 9 state coulomb, or ESU, or you can say Franklin. Apart from this, there are some different unit of charges like EMU, that is electromagnetic unit, which is equals to 10 coulomb. 1 absolute coulomb is equals to 10 coulomb. Faraday is the largest unit of charge. 1 Faraday is nearly 96500 coulomb. Once again, we'll have a fast recap of the chapter electrostatics. Electrostatics is a branch of physics, right, where we will deal with Study of charges which are at rest. Electro, related to electricity, and electricity cannot be generated without charges, right? Statics means charges which are at rest. Fine. In that, your 12th standard first chapter is electric charge and electric field. It's very big topic, electric field, which we will discuss later on. First, we'll give a brief introduction. We'll understand what is electric charge, what are the units of electric charge, right? Property of a matter due to which electric and magnetic effects are produced, that is known as electric charge, right? Matter means mass, right? It means charge cannot exist without mass. Make it very sure, charge cannot exist without mass. But converse might not be true, right? That means if a body is having mass, that does not mean that it will have charge. Okay. Now charge, there are many different types of particles, but we will discuss only three: proton, neutron, electron, right? Charge on proton is, you have to remember this value, right? 1.6 into 10 raised to minus 19. Charge on electron is minus 1.6 into 10 raised to minus 19. Yeah, plus and minus are just for taking the plus charge and minus charge is to distinguish. It simply does not mean that charge on proton is greater than charge on electron, right? Apart from units like coulomb, right? We have discussed some CGS unit of charge. State coulomb, ESU. ESU stands for electrostatic unit, right? Franklin, absolute coulomb, and then Faraday, right? Faraday is the largest unit of charge. And ESU, Franklin, these are all the smallest unit of charge. These are the relations between coulomb and state coulomb. ESU, 1 coulomb is 0.1 absolute coulomb. Note down these relations, it might come in your numericals or in your sums. Clear? So this was all about introduction of charge.